Assalamualaikum warahmatullahi wabarakatuh. My name is Habil Iman bin Kamal, metric number 072976. Today me and my teammate will be presenting about our data mining assignment, which is a case study evaluating data mining techniques for predictive modeling, specifically on student performance using machine learning techniques. Background: this project explores how we can predict students' final grades using a dataset that includes personal details like age and gender, family background, study habits, and lifestyle choices. By applying machine learning, we aim to identify students who might need academic support, understand key factors affecting performance, and also help schools make smarter, data-driven decisions. The dataset we used is the Student Performance Dataset from Kaggle. It contains real-world data collected from secondary school students. The rich variety of features makes it ideal for analyzing how different factors correlate with academic outcomes. There are three main methods of evaluations we used here. The first one is classification, clustering, and statistical analysis. The first method is classification. For classification, we compared three models: decision tree, random forest, and XGBoost. Random forest gave us the best result, with 91.14% accuracy and a cross-validation score of 0.9139, making it our top performer. It's robust, stable, and ideal for this kind of data. So for classification, its strength is it clearly tells whether a student is at risk of failing, and it is also easier to explain decisions to non-technical stakeholders like teachers or parents. Its limitation includes loss of detail. So for example, the classification output would be either a student would fail or pass as opposed to their actual grades. So it would lose the granularity of actual grades. And also, if most students pass, the model might overfit to the majority class unless handled properly. The decision impact of classification it helps early intervention for student that is predicted to fail, and it can also be used in academic planning, like for example targeted tutoring, parent communication, or resource allocation. So this here is the code for classification. We train the model decision tree, random forest, and XGBoost, and we can conclude that random forest has the best accuracy. This is the final output of the classification.
I am Muhammad Saleh bin Adam Malik. Next, let's talk about clustering, which is unsupervised learning method used to group students based on a shared attribute. We apply three clustering algorithm: K-means, agglomerative, and DB-scan. Agglomerative clustering performed the best in terms of Silhouette score, which is 0.3238, but create only two highly imbalanced clusters, 376 and 19 students. In terms of application, clustering help group students with similar learning habits or socio background. For example, school could use this cluster to form peer learning group or target support program. The main strength is uncover hidden patterns that are not immediately visible through gate. However, a limitation that is cluster may be hard to interpret. We might not clearly know why students fall into one group or another. Still, the impact is valuable. This insight can help educators understand the diversity in the student background and personalize intervention early on, even before final grades are available. Now, let's move to statistical analysis, where we use both linear regression and random forest to predict the student final grade. Here how two models perform. Random forest had the very best score in every metric compared to linear regression, which is lower error, MAE, MSE, and RMSE indicate more accurate prediction. Higher R2 score 0.81 shows stronger correlation between input and the predicted grade. Higher explained variance 0.81 means it is better capture the variation in the data, while linear regression provide an easy to understand unpredictable model showing how each feature affect the outcome. Random forest is better at capturing complex nonlinear relationship, which is why it is achieve higher accuracy. A strength of this approach is its ability to highlight most important factor influencing student success, such as study time, parental control, and previous grade. However, limitation include sensitivity to outliers in linear regression and the risk of overfitting in random forest if it is not tuned properly. The real-world impact is significant. This model can guide early intervention, support academic planning, and help school make data-driven decisions tailored to individual student needs.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin. Now, I will continue with the next part of our project. So, this is pre-processing. So, this is a code of pre-processing. So, before building our prediction models, we apply several processing steps to clean and prepare the data. So, we use binary encoding to convert yes or no values and gender into numerical form, and one hot encoding we use for columns like parental job and school related reasons. So, and we also normalize numerical features like age and grades to improve model performance. So that's these steps improve the accuracy of our model by removing noise, ensure reliability through consistent formatting, and enhance interpretability so that the result are easier to understand. Next, we move on to the feature selections. So after pre-processing is done, we perform feature selection to keep only the most important predictors. So using correlation analysis with the final grade G3, we identify top features like G1, G2, failures, MATU, and study time. So after that, we then created a new dataset with just these selected features, so that this helps us make the model more accurate, reduce overfitting, and improve transparency for educators who will use this model. Next, we look at the building stakeholder trust. So, in this session, we ensure that our model is accepted and used effectively. We took steps to build trust with the stakeholders. So, this included involving teachers and administrators in the model review, validating it with the real data, and providing training to help them understand how to use the predictions. This makes the models more practical and trusted in the school environment. Next, we move on to the ethical considerations. So, in this session, we also address key ethical issues. We made sure that to protect the student privacy and ensure the model avoid any bias based on gender or background. So, most importantly, we focus on using the model to support students, not to label or punish them. So, that's all from us. Thank you.